Hey guys, so now we're going to do the rational root theorem. And so it's going to take everything that we've learned and we're going to be able to find the solutions to polynomials. And the solutions are the x-intercepts, the zeros, the roots, x-intercepts, zeros, roots, solutions. Yeah, 4. I couldn't think of it. All right, so the rational zero theorem is, hang on. Basically, we are going to take the factors of the leading coefficient, okay, and we're going to take the factors of the last one. And we're going to make a fraction and then see which one of those works. If the remainder is 0 when we plug it in, it is a 0. It's a solution. Then we can use synthetic division to find the polynomial that's left over, and then keep going. Okay, some functions, oh, hang on. So, there it is. Let's get a different color. All right, so we have our degree, right? And the degree is how many roots there are, or zeros, solutions, roots, x-intercepts. Okay. You can have real, which is what we've been dealing with, or you can have imaginary, which is the complex one with the letters I. Just FYI. All right, now let's go into a couple of things. So here we've got a polynomial. He's already factored. Okay, when it's written like that, with the factors being multiplied together, it's called product of factors. And so to find the zeros, I'm just going to set each one of those guys. I'm just reminding equal to 0. Okay, and then I'm going to solve. So over here, I'm going to add 3 to both sides. And then I'll divide by 9. So I get x equals 3 over 9, which is 1/3. So 1/3 is one of my solutions. I'll subtract 2 on both sides. So I get x equals -2. It's a 2. I'm going to add 8 on both sides. So I get 2x equals 8. And then I'm going to divide by 2. So I get x equals 4. All right. So I get 3 solutions, 3 zeros, roots. There was 3 factors. Okay. Now if I multiplied all of this out, I would get probably 18 because I did 9 times 2. I would get x to the 3rd, and so the degree would be 3, and so that means that there would be 3 solutions. All right, so too many times. Okay, so let's excuse me. We're gonna go back to this in a minute. Oopsies, I thought that was a highlighter. Just kidding. P and Q, P factor of this, Q that. I'm gonna go back to that. Okay, I'm just highlighting important stuff for a minute. While I have my highlighter open. Don't grow something off. Okay. I'm gonna list all the coefficient of the highest power. So that's this guy right here, and that coefficient is 1. That's kind of bad. All right, so I have 1, and so the factors of 1 are just 1 and 1. So I just have plus and minus 1. I put plus and minus because it's the positive and negative factors. All right, now the constant term is this 3. And so the factors of 3 are 1 and 3. All right, this hang on. Yeah. All right, just because there's, let me delete that right there. All right, they're calling, and most math books call it P. All right, they're calling P, okay, the factors of the constant, this guy is P. And they're calling Q factors of that guy, right? So I'm just labeling it, right? And we need to do P divided by Q. What I do is I put P, all my P's over all my Q's. Ugh. I am like silly today. I should have written number 3. Right, P over Q. Okay. Then you reduce. So we're going to do that divided by that. So that is 1 over 1. So we just get 1. And then we do that and that. And we get 1/3. Plus minus 1/3. And so there's 4 possibilities. Plus 1, negative 1. Plus 1/3, negative 1/3. For our possible rational zeros. We're not finding them right now. All right, let's do another one. Okay, right now. So this guy, I intentionally kind of made a little hard so that we could just practice the skill. I'm not necessarily going to give you one that's this complicated. I just want you to practice the skill. All right, list all the possible rational zeros of f of x equals 21x cubed plus 18x squared plus 9x minus 12. Okay, so we need to do p over q, okay, and p is the last thing, so 12, and q is the first thing. It's funny that this is a fraction bar. Kind of funny that they're opposites. Gosh darn. I'll get a different color. I want you to make sure you know that it's not just like a line, it's a fraction bar. Okay, so the factors of 12 are 1 and 12. The 1 with the 2 and 6, 3 and 4. Now the factors of 21 are 1 and 21. 2 does not work. 3 and 7, 3, 4. Okay, so that's it. So what we need to do is do 1 over each of these numbers. Okay, and so we get 1 over 1 is 1. 1 over 2 is 1/2. 1 over 21, sorry. 1 over 3, 1 over 7. And always put plus minus because it can be the positive or negative version. Now we need to do 12 over all of these. Okay, so 12 over 1 is 12. 12 over 21. 12 divided by 3 is really 4. Okay, so I'm going to write that out. And then we have 12 over 7. Okay. Now we do 2 over each of these numbers. Okay, I'm practicing the skill. I'm not going to ask you a crazy one like this. Okay. Plus or minus 2 over 1. Plus or minus 2 over 21. Plus or minus 2 over 3. Plus or minus 2 over 7. Now we do 6 over all the numbers. Okay. So 6 over 1 is 6. 6 over 21 is divided by 3. So we get 2 over 7. Okay. Then we have 6 divided by 3, which is number 2. And we have 6 over 7. More. Can fit it somehow. 3 over all numbers. Okay. 3 divided by 1. 3 over 21 is the same as 1 over 7. So minus 3 over 3 is the same as 1. 3 over 7. Okay. Now we have the last one. In case you couldn't tell. 4. I know I've used this, but you can't really tell. Over all of them. All right. Really, they should like be in an organized manner. I write really big and I write crooked, so my illegible handwriting is going to cause some confusion. All right, so 4 over 1 is 4. 4 over 21 doesn't simplify because 4 is even, so it's only divisible by 2. 4 thirds, and then 4 sevenths. Okay, here's the kicker. You have to cancel anything that's already been written. For example, we already have a plus and minus 4, so this guy goes away. And plus minus 1/7, so that goes away. And we already have a 1, so that goes away. So what I normally do is I start over here from the back and I start from the front, and then I see like, hey, do we have any other 3/7? And the sevenths should be right here or over here. You know what? 12 over 21 simplifies. Divided by 3, you get 6 over 7. 6 over